7th grade chemistry lesson plan. Specifically, this is the fundamental basics of phase change in regards to H2O. Our objectives for this class are that the students would understand the physical phase changes, the concepts of evaporation, condensation, and sublimation. The students should be able to relate to me or to give examples and relate environmental aspects and according to the water cycle, examples of each stage. The key elements that we need to understand is that phase changes require an input or an output of energy. This is energy which is the capacity to do work. Specifically for water, these are molecules that are tightly compacted in the liquid format. This is kinetic energy, which is energy in motion. So we go from our solid to our liquid to our gaseous state of water. This requires an input of energy. This involves breaking of molecular attractions. When we move from our gas to our liquid to our solid, we are forming molecular attractions and we are releasing energy. With water, when we're in liquid state, we're tightly compacted. As we add a heat source, the molecules will begin to move faster. The kinetic energy, they're moving faster. As we move to a gaseous state, the molecules will then escape into a gaseous state. On the other end of the spectrum, we have tightly compacted water molecules from liquid. Now we're freezing. As we're freezing, we are forming a crystalline structure. In this process, our molecules are dispersed. They're not as tightly compacted as liquid. So this is the reason why ice will float in water. As we move forward, one key fact that we need to keep in mind is that the covalent bonds of H2O are not broken during any of the phase change processes. They stay intact. What is changing is the molecular attractions. They're broken or they're formed. H2O is a compound. It is a pure substance of two elements, hydrogen and oxygen. Evaporation will be our first phase that we'll discuss. We're coming over. I have boards around, as you know. We've been discussing this for about 2 days. This is our third day, so we're kind of going through a recap to get ready to do a study guide. Each of you has a study guide in front of you. So I'm going through the key facts that we've been discussing and getting ready for a question and answer period. Evaporation is a cooling process. In this process, energy is absorbed into the atmosphere. We're going to relate it to a water cycle. In evaporation, bodies of water such as rivers, oceans, lakes. The sun is our heating element. It'll heat up the bodies of water, and the water will escape as a water vapor or into the gaseous state, into the atmosphere. We also have evaporation as boiling. When we go home and we're boiling water on our stoves, and we have our heat element is our electrical power or our gas. The water is heating up. We have the bubbling action going on. That bubbling action is actually evaporation. We have the water vapor boiling underneath the water is being buoyed up to the surface where it's escaping as a gaseous state into the atmosphere. Sometimes we can see that as steam. We also have perspiration. Our skins, as we're outside in the sun, we get overheated or we're working, we have beads of perspiration or sweat that form on our skin. That evaporates away, cooling our skin. So that would be 3 processes in regards to evaporation, to give examples. Condensation will be our next process. This is where we've talked about evaporation, where the gas molecules go into the atmosphere. With condensation, those gaseous molecules are reforming. It is a warming process where the molecules are coming back together and joining together and forming water droplets. So this is where we have a creation of our cloud formation, and the water droplets are forming and it's falling back to Earth. So this is a release of energy, and this is where our water droplets, our rain, our snow, our sleet are coming back down to Earth, the cycle. We also can see condensation in our homes. When we take a shower on a cool day, the heat of our shower will come out. We'll see condensation on our mirrors, on our windows. So it's key to understand that this is a warming process where the energy is released And it is the formation of the water molecules coming together and forming the water droplets from the gaseous state. Our third phase is sublimation. Sublimation is where we go from a solid state to a gaseous state without passing through the liquid phase. So, and we've been discussing in our freezers, we have ice cubes. Over time, it shrinks. That would be a simple explanation for sublimation. This time of year, we have a lot of people doing dry ice and putting it in baths of water, and we can see this fog coming out, and that would be another example of sublimation. For our purposes in the water cycle, a vast, significant loss due to sublimation of our snowpack and our ice pack has to do with our mountaintops and the loss that we have there. We've been talking about Mount Everest as one of our examples. And there are 5 key components that aid in sublimation. One is the energy from the sun, higher elevations or altitudes, low air pressure, low relative humidity, and dry winds conditions. So what we're going to do now, you have a sheet of paper in front of you. It gives you the key facts. There's a series of 5 concept questions. What I would like for you to do is do a group talk. Answer those questions together while I'm getting ready for an activity, and then we'll come back together and ask and answer the questions. Boy, you get nervous up there. Should be able to see everything. What do you want me to do? Go. That's good. I forgot to start my timer. We should be about 10, 12 minutes. 8 minutes? Okay, I really went through it then. Nervous. How are we doing?
Good.
Do you need any help? Doing good?
Yeah.
I did the group section just so that I could incorporate like the extroverts, introverts, trying to get each group. How are we doing here? Do you need any help? Any questions? Pretty straightforward. How are we doing? I'm going to have a bunch of ice if you want to take it home after and play with it.
I'd love to.
Okay.
Dry ice?
Yes.
No.
I figured you would. Have some fun. Any questions of me? Do you need any help?
No, I think
Pretty straightforward, I think. Yeah. How are we doing, everyone? We ready for question and answer? Okay. We'll start with question 1, group 1. Ice is a solid form of H2O. It floats on liquid H2O. Can you answer why?
because it's less dense than the water. Because it's less dense than water.
correct?
And their covalent bonds are they're not broken, but I don't know, something to do with that.
All right. As the water is freezing, it forms that crystalline structure, so it's no longer as tightly compacted as the liquid. It's that open crystalline structure is the reason why that the ice is floating on the water. It's not as tightly compacted, so less dense. So correct. Question 2, group 2. Evaporation is a cooling process where energy is absorbed. How does boiling relate to evaporation?
When the water boils, like there's more movement of the molecules, so there's less interaction with the water molecules, so they evaporate.
Right, that boiling action is actually the water vapor is being buoyed up to the surface where it escapes as gas. Yes. Group 3, question 3, sublimation is when a solid form of H2O water goes from a solid state directly to a gas state without passing through the liquid phase. Can you name some things in our environment that sublimate? The mountaintops, yes, the snow, the tops,
Dry ice? Does dry ice do
yes,
Oh, nice.
yep. And ice cubes in our freezer would be a little way that we could see it in our homes where they shrink up over time. 4 times so we can get to our activity. Mount Everest we've talked about in regards to, this is a prime example of sublimation, and we've talked about the 5 key components. The sun is our energy source. We have sunny, dry mountaintops, higher altitudes, lower air pressure, low relative humidity, and dry wind conditions. We're getting ready to show sublimation. We're going to take dry ice, and I'm going to do it as a presentation for the simple fact of safety. Dry ice is a negative 178 degree Fahrenheit or a negative 78 degree Celsius. It is very capable of doing damage to our skin. When we put it into the water, because of the temperature change, we're going to see the dry ice sublimate. It will create a fog, which will be the gaseous state. Do you want to stay sitting, or do you want to come and stand up around it? What would you like? So I'm going to use tongs for safety. I'm going to start. Now we're going to see the bubbling action. Even though we're not hot, we're still going to have that bubbling action of evaporation. And immediately, so a lot of the schools will use this, a lot of Halloween displays. They'll have big old vats of water and put in the dry ice. The warmer the water, the more the reaction. There is another process to this to where you can, after it settles down, you can try to put a bubble film over and blow a bubble up to show the students the gas is being collected. So I'm going to attempt it. I've tried at home. I've been successful a few accounts. Let's try this one going too. Do you agree that this is a good example to show gas escaping from a solid? I mean, we can look at the ice cubes in the freezer, we can't see it happening. We can look at the gaseous state in our environment, we breathe air, it's gases, we can't see it. This is a good way to be able to see it. This is a bubble solution, it's 2 to 1. We're supposed to be able to go atop and be able to add in a different element of creating a bubble on this. Like I said, I wanted to try it. I've been successful at home, but you have to play with the bubble solution and the size of the glass bowls. Let's try this one. But this alone, without the bubble, this alone will show the sublimation. I just wanted to try to have a cool finish. If the soap goes into the water, it's a whole different experiment. We have nothing but bubbles going on. You can do this. They claim that you can do it with plastic containers. They've shown bigger containers with it being done. There we go. There we go. It's just starting to form. So what's happening is the gas is escaping. It's blowing up the bubble. At some point, the wall of the bubble will become thin, and the bubble will burst, and the fog would go down. So I do have lesson plans on the back that are more detailed, that have the recipe and pictures on the back table. If you'd like to take them, that's up to you. I have on each of your tables a half sheet of paper, if you wouldn't mind, for the evaluation to write out for me anonymously where there could be improvements to the lesson plan to help me for my evaluation. Oh, I just busted that one. I'm just having a hard time with this one being larger. Well, you can use string, you can use cloth. This is just paper towel, a thick paper towel. The key is not to have it so dripping that the bubble solution goes into the water. There we go. If it's bubbling too much, then the bubble won't form. It breaks it. So you have to kind of let it settle down a little bit. Are we right at finish? Okay, I'll get up. I'll get out of the way. Basically, the demonstration was to show sublimation. So you physically would have something to see rather than just the concept of, yes, there's gas around. I wanted you to see something physically in our environment. So we know dry ice sublimates. We know that our mountaintops are sublimating, but we really don't see it. So this was just a way for you to be able to see a gaseous state where we go straight from solid to a gas. Good.